Welcome to our podcast, Understanding Artificial Intelligence and Its Impact, where we explore the transformative power of artificial intelligence in today's world. Join us as we delve into groundbreaking innovations, their real world applications, and the profound impact AI has on industries and daily life. Tune in to stay ahead in the age of intelligent technology. Today, we have a very esteemed guest on our podcast, Soumitri Kadambi. Soumitri is a seasoned IT professional with over 2 decades of experience in delivery, development, and product management for software products. He specializes in quantum computing, artificial intelligence, machine learning, data science, and analytics in general. His experience in development of AI/ML products and other analytics applications, with over a decade of expertise in this domain. In his spare time, he also doubles up as a faculty of education institutes and independent researcher with an interest in publishing research papers in quantum computing, artificial intelligence, and machine learning. He's a dual master's holder with an MTech in data science from IIT Hyderabad and an MBA from the University of Manchester. And also, I've learned a lot from him and still to learn more. Welcome to our podcast, Soumitri. I'm blessed to have you. Thank you so much for coming.
Excited to be on this podcast as well, Pratibha. Thank you. Thank you so much.
Sure. Let's start. Thank you. So we'll start with general questions, which is introduction to AI. So can you explain what artificial intelligence is in simple terms?
Yeah. So as the term suggests, right? So artificial intelligence is something that doesn't come naturally, as in humans. That is
Yes.
something attributed to, for example, to machines, let's say, and we are expecting machines to have some amount of human level intelligence. For example, it should be able to recognize speech, make decisions, identify patterns in the data, solve some problems, and also make some inferences based on the conversations or the data that is presented to it, right? So we do have some capabilities right now to start with. The machines are able to recognize audio, visual data, etc. They're able to identify the patterns. They're able to generate summaries out of text, make sense of the textual data. They're also able to generate some, a new text based on the user prompts, right? So we do have some such capabilities already, but we are a little far away from other human level capabilities like problem
Mm.
solving, decision making, and so on. Yeah, but yeah, as technology advances, you would be able to see such capabilities also coming up, right? So now, what are some of the examples of artificial intelligence? So
Mm.
we have a wide range of capabilities available currently. There are things like recommendation systems that you see on Amazon, Facebook, YouTube. So, for example, you would be able to see recommendations of new products on Amazon. You would be able to see recommendations of videos on YouTube and so on. We do have virtual assistants, chatbots, right? For example, Siri has been around for quite some time. Alexa has been around for a decade almost.
Yes.
We are in the verge of a major revolution as far as natural language processing is concerned. We have a wide range of chatbots, translation tools, that can understand our human text and generate new textual data based on requests. For almost more than a decade now, we have, I would say, image recognition tools that can identify objects, faces, scenes, and so on in videos and images, etc. These capabilities are enabling surveillance, driving cars, and medical diagnosis, and so on. Coming to healthcare, we have tools that can diagnosis, that can predict diseases and identify or analyze medical images, and so on. Uh, we also have wide range of use cases in the financial side as well. For example, has been used extensively for fraud detection, for loan assessment. For example, if you go for a loan,
Mm.
there could be some kind of an machine learning or an AI model behind the scenes that is assessing whether a loan should be approved to you, right? So these are some of the use cases. I hope this kind of makes sense, and it's useful.
Yeah, it sounds very exciting, Soumitri. Let's see what it holds for us in future.
Sure, sure.
So let's talk about history of it. So how has AI evolved over the years, and what have been some significant milestone in its development?
Yeah, sure. So you could trace AI back to the 1920s. In fact, you can actually trace AI back to 1920s, where people were talking about it. But the most uh, I would say the most important breakthrough occurred in 1940s and 1950s. In fact, in
Mm.
40s actually, where scientists, neuroscientists, were able to kind of understand how a neuron in the brain works, right? And this was what was
Yeah.
called as a Hebbian learning, and this was identified way back in 1943. And the same approach, technology, was used by a scientist, electrical engineer. His name was Rosenblatt, back in 1958, right? And he developed what is called as the perceptron in deep learning, and the perceptron forms the basis of all deep learning technologies, right? And then this perceptron was based on certain. It was not based on software; it was based on hardware, actual electrical engineering hardware. And this perceptron was used to do some kind of rudimentary image recognition and image processing, and this was all done using, I would say, electrical resistors, photovoltaic sensors, and so on. So that is where it started. And 1950s was also when AI as a field started, and there were scientists like Alan Turing, John McCarthy, who laid the groundwork for AI. The most famous event was called as the Dartmouth Workshop that happened again in 1950s, and this workshop coined the term, as you call it, the artificial intelligence. Right. 1960s, we had rule-based systems, and an Eliza chatbot emerged during this time, and it was, in a way, similar to the chatbots that we see right now, like the Copilot, the ChatGPT. It was similar, but it was not as advanced as we have right now. Again, in the 60s and 70s, there were developments around deep learning, right? And then people were able to build some kind of deep learning models, but they did not have back propagation in place, right? And that back propagation actually happened in the late 1980s, and this was developed by uh, uh, the computer scientist. His name was Jeffrey Hinton, and this was a major breakthrough in that era, right? And while these developments were in place, still AI was mostly based on rule based and expert based system. We didn't really have extensive deployment of machine learning as well as deep learning methods in place, right? And in the 80s and early 90s, we also saw the first, what do you call, as the handwritten digit recognition algorithm. It's called as a convolutional neural network, and that was developed. And this breakthrough was made possible by Jan LeCun. He's currently the chief data scientist at Meta, and this was another major breakthrough. In late 90s, again, the IBM's Deep Blue computer was able to defeat Gary Kasparov, and this was again another major breakthrough of that era. In 2000s, we saw vastly improved compute and storage made available to the industry, and ML algorithms were improved. This era saw wide deployment and incorporation of the ML algorithms, and this led to the applications like spam filters and recommendation systems and so on. And in the last decade, we had some, again, major breakthroughs where you had video and image processing, machine learning models, deep learning models. IBM Watson won the Jeopardy. AlphaGo won the Go championship, and so on. Again, these are all major breakthroughs in the last decade. And the last probably 7 8 years, we have seen the emergence of the Chat GPT and GPT based machine learning models,
Yeah.
and I think this has created a huge wave, and people are at least trying to evaluate what this is about, right? And one of the
Yeah.
major papers that came up or emerged in the last decade was "Attention is all you need," and this is where all these Chat GPT based models started. So yeah, and yeah, this is I hope this is a small a snapshot of the AI space in the last 60 years. I hope this helps.
Thank you, Soumitri. I think you should take note for each and every word what you are saying right now. It's very insightful. Thank you so much. Okay, let's move to the next section, which is impact on society. So
Right.
first
Sure.
is job market.
Right.
So,
Right.
what are the potential impacts of AI on the job market? Will it create more jobs than it destroys?
Yeah, sure. It's a great question, Pratibha. So right now we're not in a phase where I would say that this is leading to job losses. We're not in that phase right now. We are actually in the phase where you see these AI tools actually augmenting some of the work that machines are so some of the work that humans are doing. So rather than leading to job losses, what these AI tools are doing is they are actually augmenting the work. So, for example, you
Mm.
could see some automatic prompts for some objects that are recognized in an image. Or for example, a better use case could be in a healthcare radiology image. These AI tools could automatically annotate certain features or aspects of the image in the radiology image and make some recommendation. Let's say they could say whether this member or this patient is prone for cancer or not. They could or this could diagnose whether this patient has cancer or not. It could make some recommendations, but this is definitely not taking away the job of an radiologist, right? It's doing stuff like that. So then the radiologist could look at the recommendations and make either accept the recommendation or reject the recommendation. So what it's doing is it's actually automating a lot of human tasks and making recommendations, and the human is always in the loop, and then they could accept or reject the recommendation. So we are in that phase. So right now I would say no, we're not in that phase that would lead to job losses. There could be stagnation in terms of the jobs because of these tools, but it's definitely not taking away the existing jobs. It's leading to automation. So a lot of these existing jobs are getting automated, and the key to this is humans and workers and employees need to upskill themselves in terms of the AI technologies and be aware of the various AI tools that are in play. Right. So
Hmm. Thank you. It's a relief, at least for now. Okay, let's move on to privacy. So, how does AI impact privacy and what measures can be taken to protect personal data?
yeah, sure. Right. So as we are all aware, right? I mean, all these generative AI tools and deep learning tools are based on huge volumes of data, huge volumes of training data, right? And most of these Gen AI tools, whether it be the Chat GPT or the Copilot or the Google Bard or Llama, any of these tools, they use all the openly available video, image, textual data that's all available on the internet. It's all freely available, and this could also include some of your own personal stuff, right? Some comments you made on somewhere on the internet, or some like you made on somewhere on the internet. So it's all consuming all that, right? So yeah, so yes, so there have been attempts by many researchers who were able to kind of hack these AI tools and automatically pull up some personal and sensitive data out of the model or out of these GPT tools or Chat GPT or any of these tools. So it has happened. So ethical hackers or hackers, they've used these tools and kind of extracted the training data or any other data directly out of it. So people have been able to see some of the sensitive private data as well, right? So yes, this is a very important concern. Yes, and and right now we're not in the phase where I would say people are able to address these things, these challenges. So one way of
Mm,
addressing these challenges would be to possibly de-identify this data, mask some of the sensitive information. Maybe the names could be masked, or maybe the user IDs could be masked, or age could be masked, whatever it is. All the personal information would have to be masked, and only then trained or fed into the machine learning model for training purposes. Yes, some precautions have to be taken, but I would say no, we're not yet there. There are concerns there. Yes.
yeah. Thank you, Soumitri. So let's move on to education. So how is AI being used in education and what are the benefits and drawbacks?
Yeah, I think this was a great use case actually. In fact, I myself saw this use case very recently when when OpenAI was demoing its most recent GPT Chat GPT model, and this demo was done by the Khan Academy founder Sal Khan himself, right? And the use case involved, wherein an user was trying to use one of these generative AI tools uh, for education purposes, and
Mm,
the main benefit of the using generative AI in this case would be to generate personalize the learning experience. In fact, there's a video
mm,
somewhere, you can look it up. So the user was able to personalize the learning and then quickly ask for some specific thing rather than going through a whole video training exercise. And
mm,
by asking personal questions, specific questions, he was able to personalize the learning experience, get some very good responses to the questions. The AI was also able to provide some tailored exercises and also generate some instant feedback, or rather than having to wait for feedback, right? And yeah, and in this way, it was able to address some. This particular use case was able to address some specific needs on skills and subjects, right? So this was a very good use case, and this is very cost effective. In fact, you can also go on Copilot or something and then ask a specific question. Let's say, ask what is a qubit, right? Instead of having to go through a whole video, you can just ask, tell me what is a qubit, or tell me what is machine learning, and then you can directly get responses. Or in fact, you can also ask the AI to throw some questions at you, and you can respond to it, right? So yeah, so this can personalize and tailor the overall education for you based on whatever your needs are. The main challenge with this is that it reduces the social and emotional connect, right? And then we
mm,
saw this challenge during the pandemic times when children were stuck at home, going through their online classes and all that. So this reduce the social and emotional connect and development and all that. Yeah, so there is a challenge there, and kids, of course, do not naturally know how to use AI tools or any of these online tools. So there is a learning curve associated, and some of these tools are not so easy to use. Again, Copilot is not so easy to use. I mean, it's user friendly to a large extent, but there are challenges associated. Yeah, there are some challenges and there are drawbacks. Yes, but yeah, AI in education is a great use case, and yeah, people should definitely try it.
yeah. I've tried myself, Soumitri.
Oh, that's great, Pratibha. Awesome.
Created a whole product using knowledge from this.
Sure, sure. Very nice, very nice.
Thank you. Okay, let's move on to healthcare and your expertise I think, is in healthcare also.
Yeah,
So,
yeah, yeah,
most,
sure.
what are the most promising applications of AI in healthcare and how might they transform patient care?
Yeah, yeah, sure. Yeah, actually, AI has been a little slow. Sorry, yeah, the healthcare has been a little slow as far as the adoption of AI is concerned. But yes, you already see many use cases. One very good use case that I mentioned is processing, radiology images and making some recommendations. Right? This can
Mm,
potentially save a lot of time for the radiologist, right? And this is one very good use case. There are other use cases, for example, predictive analytics to automatically predict possible disease conditions that may happen in future. So, for example, if a patient is likely to have diabetes as a health condition, or maybe have, let's say, asthma as a health condition, maybe down the line in the next couple of months, machine learning models could be, used to make that prediction. And based on the prediction, a clinician or a doctor could recommend some mitigation steps. So, for example, if a patient is likely to have diabetes onset in the next 12 months, a recommendation could be, for example, to follow certain dietary recommendations, maybe reduce the amount of sugar, or reduce carbohydrates, or increase exercising, or increase the physical activity levels, or go through HbA1c tests or sugar tests and so on. So these proactive mitigation actions could address the health risks that may happen in the future, right? And then thereby reduce the cost, right? So these are some of the things. Of course, there are other things. For example, automatic scheduling of appointments, automated claim approvals, for example. Again, these would all reduce the cost. And there are other use cases where you could see breakthroughs. For example, drug discovery. I think it's already in place. AI has been used for drug discovery. Personalizing the treatment based on genetic conditions, of a patient could be a great use case. Um, and then based on some, I would say, climatic conditions, maybe you want to predict some outbreaks of diseases, and so on. Yeah, so these are some great other use cases as well. And I think many of these are already in place, and then in the coming future you would see some of these things coming up as well.
Yeah. It's like a boon for the healthcare if used in a positive way.
Absolutely, absolutely. But again, the main or a critical part to this is the physician or the clinician has to be in the loop. You can't automatically make some recommendation. Let's say, okay, now here is a member, and this member is at risk for diabetes, and you automatically send out some, let's say,
Yeah.
medications, and that wouldn't work. So the human has to be in loop, reviewing these recommendations, and then based on these, the mitigation actions would follow.
Yeah. True. Okay. So now let's talk about bias and ethics. So how can we address the issues of bias and fairness in AI systems?
Yeah, yeah. Again, a great question, Pratibha. So, see, one of the problems with the major part of the AI or the machine learning model is not actually the algorithm. It is the data, the underlying data on which you are training, and that is where these biases would emerge, right?
Yeah.
So, for example, if you are training a machine learning model to predict some chronic condition like, let's say, diabetes onset, right?
Hmm.
Roughly only 6 to 7% of the population is prone for diabetes. The rest of the population is not actually prone for diabetes. So now,
Hmm.
assuming this distribution, let's say you go and say no, 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 or say no negative for every patient that is fed into the model. You would still have a machine learning model that has 93% accuracy, right? So this is a bias. So the machine learning model is biased to predict negative incidences in the population, right? So the outliers, however, the outliers are what we are looking at. So can we predict onset of diabetes among the population, right? So this is a great example of a bias in a model or a machine learning model. So now if you go and say no, you are actually achieving great accuracy, but then you're not actually able to achieve your objective end goal, right? So the bias and fairness, one aspect is to make sure that the data is reflective of the needs, right? That you have, number one. And you make sure that you tune your algorithm to kind of handle this sort of a bias. So in that case, maybe you may want to make the algorithm, or maybe you want to make the data, underlying data, more even by having some synthetic data within it. So maybe you want to have an even distribution of the positives and negatives, as in this
Hmm.
example. So that can be done with some algorithms. There's ways to do synthetic. uh, uh, generate some synthetic data and stuff like that. So that can be done. So you need to handle both the positive and negative use cases appropriately. Now, once you have the model in place, you need to have mechanisms to measure bias, right? And then there are plenty again the plenty of algorithms available out there in the market, out there in the industry that can measure bias and fairness. So they can kind of measure how much you're able to predict your positives, how much you're able to predict your negatives. There are even some very basic metrics, like for example, precision and recall. Precision is a measure of how well you are able to catch your positives, right? Recall is a measure of how well you are able to capture the positives, and precision is a measure of how well you are able to capture the false positives. Right? So again, you
Mm.
can't go yes to everything. For example, you can't go and say yes to all the underlying data, and then but then you are making a false positive recommendation for a non-diabetic patient. Right? There are
True.
such challenges as well in the data. So you can look at some metrics like precision and recall. There's some basic metrics to capture positives, actual number of positives, false positives. There is also an combined metric called as a F1 score that can combine. So ideally, all these three metrics should be close to 100. And then there are various other advanced metrics available, but these are some basic metrics you can look at. So yeah, so bias and fairness. One is to make sure that the data is reflective what you need, and
Yeah.
post the development of the algorithm. Look at some of these metrics that can measure the bias within the model. So, yeah.
So true. Thank you, Soumitri. It is very important to know this. Very insightful. Thank you so much. Our next section is technological advances,
Hmm.
current trends. So, what are
Yeah.
some of the most exciting current trends in AI research and development?
Sure. Again, a great question, Pratibha. So there's a few things that are emerging right now. Um, for example, one of the areas is what we call as zero shot learning or self-supervised learning, right? And what's happening here is, I mean, as you know, all know, models currently these machine learning models require huge amounts of data for training purposes. Uh, they get into easily into billions of tokens and stuff like that for generative AI. So
Hmm.
the question is, can we train machine learning models or deep learning models with minimal data? So that is what
Hmm.
is called as zero shot learning or self-supervised learning. So you take the model directly and deploy it, and then the real world data is fed into it, and it kind of automatically makes sense of the data that is presented to it, and then based on the feedback that is presented to the model, it kind of tunes its learning experience, and in the future it can uh, generate a better prediction. That is one area. Of course, like you said, bias and fairness are very important, and we need to be able to measure those. One of the
Yeah.
key things here is explainability. So, can the model be explained? A lot of these generative AI models are actually black boxes. So why is a model generating something? Right? So can you explain this thing? So it's little difficult to explain what a model is generating as an output. So explaining how and what the model is generating, it is a very key aspect, and I think that will be an ongoing area of research going forward. Multimodal AI, that's another thing. So currently, most of these models they only use textual data or image data. Can we have a machine learning model that can combine image, text, visual inputs, audio, etc., to generate output? So multimodal AI is another area for research. Quantum computing is coming up pretty well. There have been great advances. Can we run machine learning models on quantum computing? So this could reduce the need for compute. This could reduce the amount of data that you need, and then so on. And then it could maybe even reduce the power consumption, right? So quantum machine learning is another area. Deployment of AI on edge-based devices, like smartphones, IoT devices, is another very hot area. And so finally, like I said, continual learning, ability to learn based on the user input and so on, right? So that will be another area that will see great advances in the future. And finally, people keep talking about artificial general intelligence. So intelligence that closely resembles humans, which can do a wide range of problem solving, which can do some decision making, and this could have very good use cases in robotics and so on. So we're not defined what AGI is, or we're not defined what artificial generative intelligence is.
Yeah.
So when we make advances, when we define this very clearly, so you will see AI that closely resembles human capabilities.
Yes. Can you give just a bit of layman terms definition of quantum computing?
Yeah, quantum computing is a radically different paradigm of computing, actually. So what we do right now, it's all classical computing. So classical computing is, based on semiconductors. You have transistors, billions of transistors running on CPUs. I
Hmm.
mean, any electrical engineer would be able to define it. So there are CPUs which run on certain speed. There are limitations to what a classical computer could do. I mean, what we use is a classical computer. The limitations could, with respect to what it could do. As we already see this, right? I mean, you can't solve certain types of problems with a classical computer. Some complex problems, for example, drug discovery. You can't efficiently solve them in a good or a decent amount of time. Now the paradigm changes. Instead of running this on semiconductors, can we use physics or quantum mechanics, the paradigm in quantum mechanics, to actually um, uh, build or develop the computer? So instead of bits, you would have qubits. Qubits are basically a unit of information that is naturally used everywhere in physics, right? So, and then can we use such phenomena, use qubits? You can build entire processing systems based on qubits, right? There are algorithms, quantum algorithms. There have been
Hmm.
attempts to build machine learning algorithms based on quantum computers. There have been attempts. But again, it's going through a rapid development, and you could see advances that will bring up some benefits to us.
Sure. Thank you so much, Soumitri. So let's move on to future of AI. So where do you see AI heading in the next 5-10 years?
Yeah, so AI is poised for rapid development in the coming years. What we
Yeah.
have right now is pretty rudimentary, actually. So you go and ask a
Yeah.
chatbot, it throws up something, but it's still rudimentary. For example, you ask a chatbot to generate some music. I tried it myself; it was not very satisfactory.
Hmm.
You have some conversations; it's not able to kind of make sense or grasp what you are trying to say. So there will
Hmm.
be rapid developments in the future where you would see, with some minimal prompting, it is able to grasp your context, grasp your intent, and then generate the outputs and actually make sense of what you really want. Right? That will be one great area, right? And then you would be able to generate the kind of images that you want. You would be able to generate the kind of videos that you want, and then this might potentially disrupt a lot of other areas. For example, advertisements. So can you
Hmm.
generate a quick ask and chatbot, let's say, to generate a quick 30-second video for some advertisement or commercial for some product, right? And
Hmm.
then it automatically generates. I think that you can see it, but it's not so easy right now. But if it can happen, if it can be made to happen, that will be one great area, right? Um, there are a few other things. So, for example, robotics and automation would be one great area for progress using AI. So
Hmm.
currently, we don't. I mean, there are companies like Amazon that are using robotics within their warehouses, but it's
Hmm.
not human level, right? So now, can we have robotics where you have human level intelligence within a robot, right? And then a human, for example, an elderly person could talk to this robot and then
Hmm.
ask for something. maybe get some check done, or maybe ask for something, and then it is able to address the needs of this elderly person, or maybe take care of this elderly person in some way,
Mm.
and that would again lead to a breakthrough. So this could, I mean, this will not take away some jobs, but this could help an elderly person get some much needed attention when there is no human, right? And this is a very good example where a breakthrough could happen. And then a lot of companies are already working on it. For example, I was recently reading some article. Jeff Bezos had invested heavily in some firms which are working on such technologies. Yeah, so this is work in progress. Yeah, so you'll see a lot of advance coming in the next future. And then artificial general intelligence. Again, the
Yes.
definition is not clear, like I said. Yeah, you'll see some advances at least in the next couple of years.
Yeah. It sounds very exciting. Let's see where we are heading towards. Thank
Yeah,
you. So next is very interesting. It's and that is human AI collaboration. So how can
yeah.
humans and AI systems best collaborate to solve
Mhm.
complex problems?
Sure, sure. Humans and AI are meant for different purposes. They're not, they don't do the same thing right now. I mean, there are some evidences here and there, but they don't really overlap that much. Humans are more optimized for intuition, creativity, problem solving, and so on. AI, machine-based AI, currently is more optimized for speed, rapid processing of data, and quick generation of insights. I mean, it may be correct, it may not be correct, but yeah. So they are complementary in nature, right? For example, humans can't process trillions of volumes of data and generate insights, but machines can do.
Yep.
On the other hand, the AI cannot make quick decisions. So there is a need for great collaboration between these two, and with this combination of human and AI and machine, you would be able to see great productivity gains coming up in the future, right? And we already see some of these things with our chat GPT types tools, where you can quickly ask for something and you get something, and then the conversation goes on, right? This could be, I mean, I wouldn't say use it for medical diagnosis healthcare, but you could try to use it. There are some use cases where somebody used it for diagnosing some rare healthcare conditions, and they were benefited.
Mm.
Even today, also, I was seeing that. And now, if you are able to incorporate continual learning, right? This will be even more powerful. So you present some feedback to the AI model. The model kind of generates or learns from the feedback, automatically incorporates corrections and so on, and then yeah, it becomes even more powerful. So yeah, so these are some use cases that I see, Pratibha.